to Teacher Gimbal channel. If you like these videos, please like and subscribe, and let's go right back to where we were. So we were talking about this function, and we had said if we have miles d, this is going to equal 30 times 16 minus x, where x represents the amount of gas that's left in the car. We want to write an equation that makes it easier to find the amount of gas left in the tank x if we know the car has traveled d miles. Now in the last video, when we had miles, we had to evaluate for d. So we had to do 90 is equal to 30, 16 minus x, and then we had to go ahead and solve for x. That's a lot of work, so maybe we want to make our lives easier. To make our lives easier, we're going to do something where we solve for x within the function. So that means we're going to isolate x before we evaluate it at any numbers. I divide both sides by 30, and I get d over 30 is going to equal to 16 minus x. I'm going to subtract 16 from both sides. This goes away, and I'm going to get d over 30 minus 16. Remember, you cannot subtract with a variable, so we just have to leave that minus 16 over there. I have a negative x, which I don't want, so I'm going to multiply this side by negative 1. I'm going to multiply that side by negative 1, and I'm going to get negative 1 d over 30 minus 16 is equal to x. If I didn't like that negative 1 out front, I'm allowed to distribute him, and I get negative d over 30 plus 16 is equal to x. This way, if I wanted to figure out what amount of gas is left in the tank, all I have to do is I replace my d with whatever number, which would be the miles that I traveled. I would divide it by 30, and I would add 16, and I would get my answer. And that makes my life a whole lot easier. You're going to see that skill all the time. You're going to see it throughout math, but you'll also see it in physics and science classes as well. So it's a useful skill to know how to solve for a specific variable. Problem number 2. The area of a rectangle is represented by the formula A is equal to L times W. Where L is the length and W is the width. The length of the rectangle is 5. So I like to go ahead and I like to always draw a picture. Write an equation that makes it easy to find the width of the rectangle if we know the area and the length. So area is equal to length times width. I always draw my L's like that so we don't get them mixed up with 1. We know that the length of the rectangle is 5. So I'm going to say A is equal to 5 times W. And I want to know what is the formula or an equation that makes it easier to find the width. So I want to solve for the width, which means I want to get the width by itself. These cross out. I'm going to put the W on this side, and I get the area divided by 5. So if I know the area and the length, which in this case is 5, this would be my formula. If I didn't know it was 5, I would do something a little different. I would start with the same equation, and I would say area is equal to length times width. And if my length is not 5, I just divide both sides by L. So area divided by L is going to get our width. And in this case is a specific scenario when the length is 5, as we were told in this example. But again, we're solving for a specific variable in a formula, which is a super useful skill that I promise you will see over and over again. So it's a good idea to learn it now. Problem number 3. Noah is helping to collect the entry fees at a school sports game. Student entry costs $2.75 each, and adult entry costs $5.25 each. At the end of the game, Diego collected $281.25. Good job, Diego. Select all the equations that could represent the relationship between the number of students S and the number of adults A and the dollar amount received at the game. So we're going to start with our problem, and we're going to write our own before we even go over here. So I don't know how to get rid of that. Okay, we have student entry is $2.75. So we're going to take $2.75 and we're going to multiply it by the number of students, which is S. Then he collected $2.75 times however many students came to the game. An adult entry is $5.25, and we're going to multiply that by the number of adults who came. We know in this scenario, Diego collected $281.25. When we're writing an equation like this, we're going to keep our units out of it, but we're going to add them back in at the end. So let's look at our answers. Here we have our 281 minus our 525a is equal to 275. Let's see if we can turn him into this. So clearly we subtracted 525 from both sides, or 525a. And you have to be careful here, because although these cross out, we get 275 times s is equal to 281.25. Remember, because this has a variable on it, we cannot actually add or subtract him from here, so we're just going to write him side by side. Does this guy match that guy? He does. He's one of our good answers. Hooray! Now we're going to go back and we're going to erase this part, and we're going to keep working from our original equation that we wrote. Can we turn this guy into that guy? Okay, well, that looks like it might be a lot of work, but we'll give it a go. In this case, they isolated the a. So let's isolate the a by subtracting 275s from both sides. My s's and my 5's look a little bit similar. So we have 525a is going to equal 281.25 minus 272.75s. Now we want to get the a alone, so I'm dividing both sides by 525 because that's going to get the a alone. But if I do it to this, I have to do it to every single term on this side. So I'm going to have 281 divided by 525. And I'm going to subtract 275 by 525. There are too many similar numbers here. 525. And my s is over here. He doesn't go anywhere. It doesn't matter if he's on top or on the side. It's the same thing. So let's check if our numbers work. So we have our a, and this term has no number, so we know that matches this term that also has no coefficients. So I'm going to pull out my handy dandy calculator. My favorite calculator is Numwork. You can get it on your phone, but you can also have a handheld version of it. I am not paid by Numwork, but that is my favorite calculator. And I get 557. Okay, we're looking good. In the second term, I'm not going to simplify because it's not simplified in our answer. And it's 275 over 525s. And this guy's good too. Party! And now we erase the work, and we're going to go ahead on to the next one. If you're having trouble following what I'm doing, I need you to pause the video and just rewatch. Watching it a few times sometimes helps. Let's go on to our next one. We have 281.25 minus 525 is equal to a. Well, we just solved for a and we got this guy. So if we solve for a again, we're not going to get something different. So we actually can cross him out. And looking at this, we can say here, hey, he solved for a as well. And this guy doesn't work, so we can cross him out as well. So now we have to check this guy. Now, visually, I can tell if this answer is right or wrong, but let's solve it so we can match. So we have 275s. We want to get him alone, so we're going to subtract 525a from both sides. 525a. These go away, so we're left with 275s is going to equal 281.25 minus 525a. Looking at this, I see it matches here, and we're not even done. We have to divide both sides by 275 to get the s alone, and that's not going to equal here when the s is alone, so we get to cross out that answer. So work smarter, not harder, to get your answers, and it's going to save you time. Let's go on to the next one. Problem 4. Volume is equal to pi times the radius squared times h is an equation, or pi r squared h, is an equation to calculate the volume of cylinder V, where r represents the radius of the cylinder and h represents the height. Remember, your cylinders look something like this. Your radius is here, your height is there. Which equation allows us to easily find the height of the cylinder because it is solved for h? Okay, he already tells us what to do. Or maybe she. I don't know who wrote the question. We want to solve for h. So let's get rid of all these terms. To get rid of them, because it's all multiplication, we're just going to divide by all those terms. And we're left with this. Volume is pi over r squared is equal to h. And we're done. Don't make your life hard if it doesn't need to be hard. Pause if you need help, and we're going to go on to the next one. I thought that was going to move. I think I have to do my arrow. Problem number 5. The data represents the number of hours 10 students sleep on a Sunday night. Are there any outliers? Explain your reasoning. This right here, I recommend you to go back to the statistics lesson on outliers, and we're not going to do it right now. That is lesson 14, unit 1, which I already have the video posted. So I'm going to send you back there if you need this one. Problem number 6 is lesson 4, equations and their solutions. It is a quick question, so we're going to do this one. The table shows the volume of water in cubic meters V in a tank after the water has been pumped out for a certain number of minutes. Which equation could represent the volume of the water in cubic meters after t minutes of water being pumped out? So we have the volume of water in cubic meters. We have the time, so we go from 0 to 5 to 10 to 15. Now let's figure out the rate of change between these two values. Now, if you can see the rate of change, that's great. If you're having a hard time seeing the rate of change, what you're going to do is you're just actually going to subtract these terms. So you're going to say 30 minus 27.5, and we get 2.5. Let's check if the rate of change here is the same. 27.5 minus 20 is going to be 7.5. 7.5. So we're adding, and then we're going to have 20 to 7.5. We do 20 minus 7.5 to figure out what the rate of change between those two values are, and we get 12.5. That is 12.5. So I know that this is not just a linear expression. We are changing by a different amount each time. We go from 2.5 to adding 7.5 to adding 12.5. So we are starting at 30, and we are going to go ahead and we're going to be adding I don't know the answer off the top of my head. And we're done.